and he's going to talk about electrical safety. This is one of the most common problems that we see as we go around and do risk assessments, and so it's something that each of us needs to be aware of and take action when we see problems like this happening, because the consequences are very great. Is that working for you, Brent?
It's working.
I can see your screen.
All right. Hello, everybody. We're going to talk about electrical safety. We're going to talk about some of the different hazards and things that can go on with that, and get a better understanding of things that we can look for to hopefully prevent accident and injury with electrical. And so we don't want to take chances with things. We want to be able to identify the hazards in whatever your work area is. We want to identify those and take care of those so that you don't have any problems. So let's talk about some of those today here. What is electricity? Well, it's flow of electrons, and just like with a lightning storm, electrons and electricity travels through different conductors and wires and things that we have that complete circuits. And so it's really a powerful thing. It's got a lot of energy behind it, and it's something that you just don't want to mess with and get caught up in, because there's some real hazardous things involved with that. And so we want to talk about those. We want to talk about how electricity always seeks the ground, and how you don't want to be part of that ground where the current could pass through you and have health effects from that. Some things to talk about too are that it can be lethal in small doses, not just a large lightning bolt, but even small milliamps of energy and current passing through you can cause some real damage and health effects. So we want to understand that. What is electricity? And there's a formula to determine the volts, and what that is it's your amps times your resistance. And so if you understand the amps and power going on there with the resistance, it gives you your volts. And it's that formula V equals IR that gets you that information. So we want to understand those basic components of electricity and understand how it works. Some things to think about is, are you conductive? Is it possible for you to get caught up into an electrical circuit and have a current pass through you with certain amps? And it's definitely possible depending on the conductivity. Some things to think about are how electricity passes through different conductors, and metals are very, very good conductors. That's why they have the copper wiring inside of all the wiring in the electrical circuits. And so metals are highly conductive. There's water and other things that electricity could certainly pass through. And that's why we have insulators. That's why on the outside of your wires you have plastic or rubber or whatever it might be that protects those electrical currents from coming in contact with something else and having electricity go places that we don't want it to. And so realize that when you're looking around your facility and thinking about things and using tools and equipment, think about the different conductors and what might conduct electricity and what might insulate it, and watch for those things to prevent the hazards with that. So think about your ladders, your tools, anything you use that might get in the way of that, and even yourself. Are you conductive? Do you have moisture on your hands, or is there humidity in the air, or are you exposed to open circuits where you could become part of that current? Think about those things in your work areas and watch those hazards. There's some shocking realities. OSHA does a lot of studies on this, and they look at statistics, and they find that about 30,000 people get injured every year from electrical shock. About 1,000 people are killed every year as well, and that's a lot. Electricity is really a big hazard that we have to watch for. It's one of the things that we find the most on our risk assessments that we do around the state, and we have to really be aware of those things because people get really injured and hurt from these things. So I'm going to show you a few examples now. These are some cases that come from some claims that have happened in the past, and they're real life things that happen to people. So the first one here, we had a guy that was in a gym. He was going to turn off some lights, and he took a key to put into a switch to turn those lights off. And as he put that key in, there were a bunch of sparks that came out, and the employee was electrocuted. He ended up having third-degree burns to his hand and his fingers, caused some real damage there. And some interesting things is that it was enough power to melt the key and the key ring. So think about all of that heat and all that current passing through there on his hand and how that might have been a real hazard there and something to watch for. Obviously something went wrong. Something was open in the circuit or came in contact with some conductor there and became a real problem. So watch for those types of things. Here's another example. Employees working outside, there were some gusting winds blowing really hard, and they blew power lines into a track hoe, and the employee that was on it was shocked. And another example of how, be aware of your equipment, be aware of those things that are conductive, and watch those overhead power lines, because they can come down or you could come in contact with those. Another example, we had an employee that was chopping food on a blender, and it was working on top of a metal table, and as she was in contact with that, there was some sort of current coming out of that blender, and it ended up shocking her on the arm and the stomach from being in contact with that metal table. Another example of checking your equipment, making sure that everything's enclosed, making sure that the electricity isn't going to go anywhere that you don't want it to. Here's a situation. There was a breaker panel, and they had an unused water heater that became turned on by accident. They didn't expect it to come on, and the public workshop ended up catching fire as a result of that water heater being turned on. So know your facility, know what equipment's there, make sure things are disconnected, covered, that you don't have any unwanted heating or fires or anything like that for electricity. Here's a really bad one. We had a contractor that was working on a substation. They thought the substation was isolated, but guess what? It wasn't. Really bad situation there. So always be aware of electricity and respect it, because it's very powerful, and you don't want to get yourself or others caught up in something bad like that. Always be aware of those things around you. And think about your own safety. Keep safety first at all times. When it comes to voltage, some people think that greater voltage equals greater danger. Well, that's certainly true in some cases, but sometimes not. Sometimes even as much as 120 volts, or even small amounts, can really do some damage to people. It's estimated that more than one death per day would happen from 120 volts. So think about it. It's not necessarily the voltage. It's not necessarily all that high voltage power. It could be simply the complacency, and that's what gets people caught up into problems. They take shortcuts. They don't recognize the hazards. Maybe they're not using the right tools and equipment, and they're complacent on things, and that's what ends up catching up to people and getting them killed or really hurt from it. So always respect that. Always respect the hazards and things that could go on with electricity. You just don't want to take chances with that. It's a high hazard thing you don't want to mess with. So when it comes to injuries, here's some types of injuries you might see with electrical. One is shock, electrical shock. The other could be burns. As the current passes through your body or different parts that could be touching open circuits, your skin and your internal organs can heat up, and you can have some severe burns from that. The other is electrocution, where the current actually passes through your body or passes through certain parts of your body that can do some real damage to your body. So watch for that. Arc flash. This happens at breaker panels and other places where you get explosions coming out of panels with molten metal and some high heat temperatures coming out of there, which can really happen to people working on panels and live electrical. So you have to be really careful with those. And another thing that could happen are fires. Things can overheat so much to where it causes a fire, and you can certainly be injured from the fire itself or from smoke or any other heat-related things from that. So watch for those injuries and things that could happen with electrical. When we think about shock, when the electricity passes through your body in a certain current, there's a lot of things that kind of make that up. But you don't want to be part of that circuit. You don't want to be the one that completes that and has that current flow through your body. There's a couple things that can happen. Is you can have health effects from that current passing right through your body, or it could be a indirect thing where, let's say you're working on a ladder and you're working overhead with your arms above your head, and you take a shock to your arms. It could cause you to lose your balance and fall off and get injured from the fall. And so sometimes it's that shock that goes through your body, and sometimes it's an indirect thing where you have an injury associated with the shock. And so be aware of that. I think the thing to think about here is always remember that it can happen to you. It could happen to anybody, and you don't want to just think that you're immune to it. Always be aware of what's around you. Watch for those electrical hazards and how to protect yourself there. Do what it takes to keep yourself safe. Put your safety first there. So what happens with electricity as it passes through the body? A couple of things, and there's some factors that determine the effect of it. One is the amount of current and the voltage as far as what's passing through you. and it happens to be possibly some resistance. So if you've got insulation, say you've got some good gloves or something like that, there's certain resistance and things that can eliminate the effect on the body as far as the severity. But the path through the body makes up a big difference. You know, you can think about, what if the current were to pass through your leg versus a current passing through your heart or through your head or your brain. Obviously that current's going to have a lot more impact on those certain organs in your body, and so the path and the duration, the amount of time that you're in there and the direction that it goes through your body, those are all things that lead to problems there, and it affects the body differently. So realize that. So what type of electricity can we feel? They say about 1 milliamp AC or 5 milliamps DC is something that you can actually feel. There's sensation to it, and you can tell that you've been shocked. If there's more than 3 milliamps, they say that you'll feel a painful shock, and you could have an indirect accident. It could cause you to jump or to fall or to jump back. That's something that you could feel, and it would be painful. Greater than 10 milliamps, there's muscle contraction. This is where if you were to touch some open circuit or grab onto a line, your muscles contract to where you can't move them anymore. It takes over, and you could be on there for quite some time onto a circuit there. Greater than 50 milliamps, this is where you have ventricular fibrillation. This is where it affects your heart. It's sending a current through your heart, through your body, at an amount that it's greater than the impulse that your heart is sending, and so you have to watch for that as well. 100 milliamps to 4 amps are fatal. These are higher amounts and definitely harmful on the body. Greater than 4 amps, you're going to have heart paralysis and severe burns, and so watch for those. You don't want to mess around with things. Even at smaller milliamps, you can see that the smaller amounts can be enough to cause an injury or have health effects from it. So don't take those chances. Be aware of the hazards there with the electricity. OSHA has a bunch of regulations on this, as you know. There's some things we're going to point out here that are important to note, and there's many other things that we won't have time in this presentation. But here are some of the main things that we want to look at. Electrical equipment must be free of recognized hazards that are likely to cause death or serious physical harm to employees. So what this means is that things need to be covered up. You don't want exposed wires. You don't want tears in insulation with copper wire hanging out. All of your junction boxes, your panels, your wiring, it all needs to be enclosed and contained. And so look for that. If you see conduit missing on an electrical line, or if you see panels open with holes or openings in it, make sure that those things get covered up, because you don't want to expose yourself or others to the hazards that could be there with the electricity. So watch for those and cover those things up. When it comes to splices, where you've got wires coming together, remember this should all be in conduit in the work area. It should be covered up. And you know, here's an example. You've got some electrical tape covering the splice, which is a good practice. It's a good material to use. However, the insulation must be equivalent to that of the conductor, and so you'd want to have this covered up with the right type of material. You'd want to make sure that that matches and that it adequately protects the wiring that's inside where that insulation is. So realize that. Make sure that those splices are covered, and it's, you know, best to have things covered up in conduit there. When we look at electrical panels, they recommend, actually OSHA requires, a 3-foot clearance around these work areas. And so it's 3 feet in front of the panel, and it's also 3 feet to each side. What happens is a lot of times people will stack boxes or materials or other tools and things in front of these panels, and it restricts access to opening the panel. So let's say there was an emergency situation where you've got sparks coming out of an outlet, or you've got things overheating from electrical, and you need to get to that panel to shut that circuit down. If you've got things in the way, that's going to restrict your access, and so they recommend you mark out the clearance area on the floor. Take some red paint and mark a 3-foot clearance zone around those panels so that people can safely get to that. That's something that we see regularly on our risk assessments that we recommend people do there. As far as identification, looking at panels, this is a great example of how to label your panel. You open it up and you see a lot of breakers. Sometimes you may not know what that stuff goes to, but if it's clearly labeled and marked as to what each one goes to, you should have no problem identifying that. One note is that it needs to be durable enough to withstand the environment. So if you've got these panels outdoors or in other areas where there's maybe high humidity or high temperature, anything like that, make sure that they're durable enough to stay labeled on there. And it's important. It's important to know what your breakers go to. Here's an example. One time I was working on an outlet below a sink I was changing out, and I knew that I needed to shut the power down because I was going to be opening up the outlet and rewiring things. And so I went out to the panel and I found the breaker, and it said kitchen, and I turned it off. And so I go back in to start doing my job, and guess what happened? I got a shock from that. And I was lucky enough it wasn't severe. It didn't cause any real problems, but it certainly could have. What happened is I obviously didn't turn off the right breaker. And so it's really important to have things labeled. It's always important to make sure and double check that things are turned off and locked out before you go working on things. So the identification is great, and that's definitely a good thing there. Overcurrent protection. So these are in place. You have breakers in the panels, and they're there for a reason. They are there to protect from overcurrents. So if the wire is inadequate, if it's drawing too much current through it, or if there's any kind of break in the circuit or any problem, those breakers are going to trip. And I'm sure you've seen that plenty of times. You know, you lose lighting in one room and you're not sure why. You go out to the breaker panel and you see that one is tripped. That's the reason why. It's there to protect people, to shut things down if something's going wrong there. And so make sure that those are in place. Make sure that they're working right, because they're there for your protection. Looking at grounding, like we talked about, whether it's lightning or whether it's electrical in a system, it's always seeking the ground. It's always trying to go somewhere. And you don't want to be part of that path to the ground. And so always check those things, make sure that things are grounded. Here's an example. There's a power pole, and it looks like it was at a park, but they had the grounding wire cut. You can see that it's not continuous from above down to the ground below. And so think about the hazard there. You know, if there's the grounding wire that's got electricity in it, you don't want to come along and touch that ground wire and have you complete that ground to the ground. So always make sure that your grounding wires are continuous, that they're in place, and always inspect. Check your equipment at all times, because you don't want to chance that and have a problem with grounding and become part of that path of the electricity. So check your cords. It happens a lot on these extension cords and ends of tools where they have the 3 prongs with the grounding prong missing. And that happens a lot. Check that out. Make sure that the grounding is there. Inspect all of your equipment. Make sure that there's nothing open or any hazards or problems there with the electrical. As far as temporary wiring goes, a lot of people use extension cords in office spaces and in workshops and construction jobs. There's lots of different uses for those cords, but the key word here is temporary. These are intended for temporary use. They're not to be used for a long-term situation, maybe running equipment for a long time or you know, running circuits. They're not a dedicated circuit. These are just a temporary electrical cord that you can use to run temporary power. And so don't overload those things. Always make sure that you're using them with the right sizing, the right type for the work that you're doing, and make sure it matches the things that you have going on there. Remember that they are temporary. So since they're temporary, they shouldn't be run through any walls. They shouldn't run through holes in the floors or any other openings. They should just be out in the open, plugged into an outlet, and temporary use. When you're done, you coil it up and put it away. Remember, it's not a permanent wiring situation for those. So with the flexible cords and extension cords, things like that, they need to be prevented from or protected from accidental damage. So a lot of times they get nicks and cuts in them. Sometimes it can cut into the interior insulation of the wiring, and you can get some of that copper wiring exposed, and that can become a real problem. So always inspect those things. Keep them free from contact, free from sharp edges, free from things that could open them up and cause a problem there. Here we have an example of a couple of extension cords and a three-way outlet where they're plugging in and extending things, but these aren't the right type for the exterior. You know, think about the weather and the rain and things that could get into there and cause damage to that equipment and the wiring there. So watch your temporary wiring. Make sure that they're used for the right locations, right type, and right sizes. When we look at electrical boxes, you know, how would it be to open this up and be missing all the breakers and have these wires sticking out? That's obviously could be a really bad hazard there. And so they have these proper covers. So any junction box, any panel, they need to have the right covers on there. And if there are openings where the breakers are, we need to make sure that those get covered up with the little breaker slots and things like that are all covered up together there. So check those junction boxes, make sure your covers are in place. When it comes to outlets, here's one that had been damaged. And maybe it's going to be repaired or fixed, but look at the hazard there. What if somebody were to come along and touch that outlet or some of the wires there and have that current pass through their body? It could be a real problem. So check that out. Make sure that things are put in place, that they're covered up, that they've got the covers on them, that they're not exposed to where somebody could come in contact with them and have a problem. Okay. Looking at wet locations. So here we have a sink and we have an outlet just to the right of the sink. Building code requires that within 2 feet of a sink you have a GFCI protected outlet. That's a ground fault circuit interrupter. And I'm sure you're familiar with these as well. You'll see the little test buttons on those where if they get tripped, the little button pops out and you have to go push that button back in. That's there as a protection to make sure that there's no differences in current. The GFCI will sense any small difference in the amount of current and it will trip, and that's there to protect the end user where they may have something plugged into that outlet. And so check your wet areas. Make sure that you have the GFCIs in the wet areas and in the places that you need. They're there to protect you. On the outsides of buildings, we see a lot of these GFCIs, and a lot of times the covers get broken off. We see these at parks and on patios and outsides of buildings. These little flaps and covers that go on there are there to keep the moisture and the rain and things out of that outlet. And so make sure that those are replaced back on there and protect those areas. Here's an example of a GFCI that's used for a portable application. I've seen these used with generators on different projects. What happens is that the generator, they'll plug in the GFCI and then they can run their power tool from the other end of that plug out there, and so it's protected with GFCI protection. If you need that for portable jobs or if you're mobile and doing things, those are what you would want to have there for the protection. When it comes to power tools, a lot of hazards happen with this. People get into trouble with getting exposed to different wires and things getting torn in the insulation on the wiring and things getting exposed, and they get shocked from it. So make sure that you're checking your tools out, whether it's a drill or a saw or any other type of equipment that has a cord on it. Check that tool and that cord for any damage. Here you can see there's some strain going on the cord. You can see that it's being pulled away from the equipment and obviously could cause damage and open up the wires there. Other things you want to look for on your tools are the grounding. You know, we talked about how electricity is always trying to seek ground. Well, that's what the grounding purpose is for. Check those little 3 prongs on the end of the cord, and if it doesn't have 3, if it only has 2, it's possible that that tool could be double insulated. And what that means is that it's all contained. It'll say right on the tool handle, it will either say the words double insulated, or it will have a little marking where there's a square inside of another square, indicating that there's double insulation on that tool. So if it's there, the 2-prong is fine. However, if the grounding prong is supposed to be there and it's not double insulated, you better make sure that the grounding pin is in place and that it's all correct. Don't take chances with your tools and equipment, because there's a lot of people that get shocked from that as they wear out and get used over time. Maintain those things. And when it comes to working on live electrical or high voltages, maybe you're going to change out some different circuits in your electrical system, you want to make sure that you have a qualified employee do that. A qualified person that knows the hazards, that knows how to work around these things. They have the necessary training, which includes on-the-job training. They've got demonstrated ability, that knows how to work on these things safely and understands how electricity works. You don't want to be just putting anybody out there taking chances working on these things where they don't have the necessary tools or equipment or knowledge to do that safely. So always use a qualified person when it comes to these types of things. And reason why is because it's such a hazardous thing. Electricity, again, is something that you just don't want to mess with. A lot of injuries, a lot of accidents happen from these types of things. And I like this picture here, these few pictures, because it just makes us think, you know, are we putting our kids or are we putting ourselves in bad situations without even knowing it? Are we unaware of these hazards around us? Think about it. Think about, you know, where you could be exposed in your work areas to electricity and other hazards like that, and take time to correct those, because you don't want to be having problems with that. In summary, you know, respect the electricity. It's a high, powerful thing. Like I said, there's a lot of accidents and injuries that people have from this, and we have to always be on guard to watch for those things. Take time to inspect your equipment, look at your work areas, see if there's anything that stands out that you might need to identify and correct, so that you and your workers are not exposed to any problems there. It's really your life and your safety, and think about it. Think about the things you need to do there. And really, there's a lot of different things that we could talk about with electricity. It's, again, one of the higher hazard things, so don't take chances with that. It's really important to be aware of those things. Jason, do we have any questions?
Let's see, I'm not seeing any questions that have come in, folks. You can type them into your chat box or the Q&A box. Like Brent said, this is serious business. We tend to get a little complacent around electricity until something goes wrong, and so each of us definitely should look around our workplace and be aware of the hazards there. All right, I'm not seeing any questions come in, folks. You must have covered it so well that everybody doesn't have anything to bring up. Doug, you got anything to add?
You know, we really do see a lot of these issues as we go around the state doing our inspections. And, you know, it's just really important to remember that, you know, if you see any exposed electrical wiring, you know, missing cover plates, things like that, you know, just telling yourself not to touch that really isn't, you know, risk management. You know, that we need to make sure, and it's a bad assumption, because you may not touch that spot or be aware of that hazard, so you leave it alone, but somebody else comes along and inadvertently comes into contact with it. It's just really important. If we take a cover off, or if there's a broken cover, we need to replace it. The temporary wiring is something we see an awful lot of. That wiring can get damaged easily, especially if it's used, you know, pulled around a corner, a post, around a hard piece of metal. If it gets left outside in the sun, where the UV damage, you know, breaks down that insulation over time, you know, all sorts of things like this. We just really need to be careful about, you know, temporary cords being used for permanent wiring, and making sure that we're covering up any open electrical, you know, splices and connections that we see out there, because those really could hurt someone very badly, and we need to not take any chances.
Yeah, where this is a safety moment webinar, we don't dive into the preventative maintenance quite as much, but that's one of the things that, as I've you know, been through my career, seen some fairly serious things happen. Just that simple preventative maintenance of actually inspecting your circuits, particularly the big stuff, and you know, it may come down to you know, a part of your PM program should definitely be thermal imaging. You know, those cameras used to be very expensive. Now you can pick one of those up that will plug into your phone, and so you use your phone as the display, but you can have thermal imaging that we can see if there's a problem with our system from feet away, and determine where our maintenance priority should be. So that's just something that kind of popped into my head. Thank you very much. I appreciate everybody's attendance and your participation there. Got some good comments coming in, and we appreciate all your work out there. Once again, we'll be doing another webinar at 10 o'clock, complete risk management. So make sure you tune into that one. If you haven't signed up, send me an email right now, and we will get that. We'll get you a hot link out there. All right. Thanks, Brent. Awesome work.
Thank you.
Everybody go out and have a safe day.